Russia, with the largest territory in the world, has roughly the same total population as Nigeria, a country 1/16 its size. But this similarity won't last long. One of the populations is rapidly growing, while the other is slowly declining. What can this tell us about the two countries? Population statistics are some of the most important data social scientists and policy experts have to work with. But understanding a country's situation and making accurate predictions requires knowing not just the total size of the population, but its internal characteristics, such as age and gender distribution. So how can we keep track of all that data in a way that makes it easy to comprehend? Complex data is more easily interpreted through visualization, and one of the ways that demographers represent the internal distribution of a population is the population pyramid. Here, the data is divided by gender, with females on one side and males on the other. The population numbers are shown for each 5-year age interval, starting from 0 to 4 and continuing up to 100 and up. These intervals are grouped together into pre-reproductive, 0 to 14, reproductive, 15 to 44, and post-reproductive years, 45 and up. Such a population pyramid can be a powerful predictor of future population trends. For example, Rwanda's population pyramid shows it to be a fast-growing country. With most of the population being in the youngest age groups at the bottom of the pyramid, the number will grow rapidly in the coming years. As today's children reach their reproductive years and have children of their own, the total population is almost certain to double within the next few decades. For our second example, let's look at Canada, where most of the population is clustered around the middle of the graph. Because there are less people in the pre-reproductive age groups than there are in the reproductive ones, the population will grow more slowly as the number of people reaching their reproductive years decreases. Finally, let's look at Japan. Because the majority of its population is in its post-reproductive years, and the number of people is smaller at each younger interval, this means that at current rates of reproduction, the population will begin to decline as fewer and fewer people reach reproductive age. Comparing these three population pyramids side by side shows us three different stages in the demographic transition as a country moves from a pre-industrial society to one with an industrial or post-industrial economy. Countries that have only recently begun the process of industrialization typically see an increase in life expectancy and a fall in child mortality rates as a result of improvements in medicine, sanitation, and food supply, while birth rates remain constant, leading to a population boom. Developing countries that are farther along in the industrialization process begin to see a fall in birth rates due to factors such as increased education and opportunities for women outside of childrearing, and a move from rural to urban living that makes having large families less economically advantageous. Finally, countries in advanced stages of industrialization reach a point where both birth and death rates are low, and the population remains stable or even begins to decline. Now let's take a look at the projected population pyramids for the same three countries in 2050. What do these tell us about the expected changes in each country's population? And what kinds of factors can alter the shape of these future pyramids? A population pyramid can be useful not only as a predictor of a country's future, but as a record of its past. Russia's population pyramid still bears the scars of World War II, which explains both the fewer numbers of elderly men compared to elderly women and the relatively sudden population increase as soldiers returned from the war and normal life resumed. China's population pyramid reflects the establishment of the one-child policy 35 years before, which prevented a population boom such as that of Rwanda, but also led to sex-selective abortions, resulting in more male children than female children. Finally, the pyramid for the United States shows the baby boom that followed World War II. As you can see, population pyramids tell us far more about a country than just a set of numbers, by showing both where it's been and where it's headed within a single image. And in today's increasingly interconnected world facing issues such as food shortages, ecological threats, and economic disparities, it is increasingly important for both scientists and policymakers to have a rich and complex understanding of populations and the factors affecting them. Statistics are persuasive. So much so that people, organizations, and whole countries base some of their most important decisions on organized data. But there's a problem with that. Any set of statistics might have something lurking inside it, something that can turn the results completely upside down. For example, imagine you need to choose between two hospitals for an elderly relative's surgery. Out of each hospital's last 1,000 patients, 900 survived at Hospital A, while only 800 survived at Hospital B. So it looks like Hospital A is the better choice. But before you make your decision, remember that not all patients arrive at the hospital with the same level of health. And if we divide each hospital's last 1,000 patients into those who arrived in good health and those who arrived in poor health, the picture starts to look very different. Hospital A had only 100 patients who arrived in poor health, of which 30 survived. But Hospital B had 400, and they were able to save 210. So Hospital B is the better choice for patients who arrive at hospital in poor health, with a survival rate of 52.5%. And what if your relative's health is good when she arrives at the hospital? Strangely enough, Hospital B is still the better choice, with a survival rate of over 98%. So how can Hospital A have a better overall survival rate if Hospital B has better survival rates for patients in each of the two groups? What we've stumbled upon is a case of Simpson's paradox, where the same set of data can appear to show opposite trends depending on how it's grouped. This often occurs when aggregated data hides a conditional variable, sometimes known as a lurking variable, which is a hidden additional factor that significantly influences results. Here, the hidden factor is the relative proportion of patients who arrive in good or poor health. Simpson's paradox isn't just a hypothetical scenario. It pops up from time to time in the real world, sometimes in important contexts. One study in the UK appeared to show that smokers had a higher survival rate than non-smokers over a 20-year time period. That is, until dividing the participants by age group showed that the non-smokers were significantly older on average, and thus more likely to die during the trial period, precisely because they were living longer in general. Here, the age groups are the lurking variable and are vital to correctly interpret the data. In another example, an analysis of Florida's death penalty cases seemed to reveal no racial disparity in sentencing between black and white defendants convicted of murder. But dividing the cases by the race of the victim told a different story. In either situation, black defendants were more likely to be sentenced to death. The slightly higher overall sentencing rate for white defendants was due to the fact that cases with white victims were more likely to elicit a death sentence than cases where the victim was black, and most murders occurred between people of the same race. So how do we avoid falling for the paradox? Unfortunately, there is no one-size-fits-all answer. Data can be grouped and divided in any number of ways, and overall numbers may sometimes give a more accurate picture than data divided into misleading or arbitrary categories. All we can do is carefully study the actual situations the statistics describe and consider whether lurking variables may be present. Otherwise, we leave ourselves vulnerable to those who would use data to manipulate others and promote their own agendas.